Okay, second video here is going to be in, we're going to simplify each expression by either adding, subtracting, multiplying, or dividing rational expressions together. Now, just to make sure that you understand, a rational expression is the division of two polynomials. Polynomials are things which the exponents on the variables are only whole numbers, meaning 0, 1, 2, 3, 4, and so on. There can be no negative exponents. There can be no fractional exponents here. So all of these are polynomials which are divided by other polynomials. And you might look at the first example and say, well, wait a minute, I've got 1 on top. Well, any constant, 1, 2, 7, 10, whatever it is, those are also polynomials, because technically I could write 1 as 1 times x, to the 0 power, because anything to the 0 power is 1. So technically that's 1 times 1 right there. So again, any whole number, or any constant, excuse me, is a rational function. So in the first example, I've got 1 over x plus h minus 1 over x. We've got two fractions. We should remember from fractions, to add or subtract fractions, we need to have a common denominator. One of the most common mistakes that we'll see on something like this is somebody might just say, oh, well, all I need to do is add h to the denominator on the right one, and I've got the same denominator. Well, that's true, that would be the same denominator. However, this is not something that we can do with a fraction. Let's go back and revisit something about fractions real quick. If I was to give you the fraction 1/2, and you were to do exactly what you were trying to say there is, well, let's just see if we can add something to the numerator and denominator and see if it holds. Let's just pick a number, I don't know, 3. Let's just say I want to add 3 to the denominator. Well, if you're going to do that, in order to try to keep the balance, you might think I have to add 3 to the top. Well, what that would give us is now 1 plus 3 on top is 4. 2 plus 3 on the bottom is 5, 4/5. That is not the same as what we started with. 1/2 and 4/5 are not the same. We can't just arbitrarily add and subtract values to a numerator and denominator. It doesn't work. What we can, however, do is we can multiply the numerator and the denominator by something in order to keep the balance, in order to keep the fraction. For example, if I had 1/2, I can multiply the top by 3, I can multiply the bottom by 3, and then we would get 1 times 3 on top, which is 3, 2 times 3 on the bottom, which is 6, and we should know that 1/2 and 3/6 are equivalent fractions. So we haven't really changed the fraction, we just changed the way the fraction looks. All right, so now let's go back to our example over here. 1 over x plus h minus 1 over x. Again, I can't just arbitrarily add an h to the denominator. And if you remember from the previous lesson, one of the other things I said was you can put a parentheses around these things in the denominator and the numerator, anything you want to, but any kind of quantity which is in the denominator or numerator, you can put a parentheses around it so that you can see that really what I have, here, moving the whole page, are factors. X plus h is a factor. X is a factor. Well, if you think about trying to get a common denominator, again, if I have like 1/2 and 1/3, one of the easiest things for us to do is to know that to get the common denominator, meaning what is a number that both 2 and 3 can go into evenly. Sometimes it's easiest just to multiply those two numbers together. 2 times 3 is 6. Well, I know that 2 goes into 6, 3 goes into 6, obviously, because I multiplied 2 times 3 to get there. So the easiest thing to do in this case is to say, well, the common denominator here is going to be the multiplication of x plus h and x. So that's my common denominator. So when I go to rewrite this, I'm going to write this as the denominator of x times x plus h and x times x plus h. And you might say, well, why didn't you distribute that? You can. It's just going to make it easier to see here, because what you're ultimately trying to do is you're trying to ask yourself, in this first fraction, what's missing? Okay, in this piece right here, what's missing? What do I have to multiply to get the x times x plus h in my denominator? Well, I have to multiply it by the x. It's the piece that it's missing. So which means what I have to multiply this first fraction by is x over x, which means on my top there, I'm going to get an x. And then you would have to ask yourself in the second fraction, what do I have to multiply this x by? Okay, this x piece right here, what do I have to multiply? Oops, sorry about that. What do I have to multiply that by in order to get the common denominator? Well, it's missing the x plus h. So I need to multiply x plus h here, but then I have to do that on top as well. Sorry about my handwriting, it's not. There we go. So if I multiply the 1 times the x plus h in the top there, I get x plus h. And this is a perfect example of where you might really want to keep this in parentheses, and you'll see why in a second. Now I do have the same denominators. Okay, I've got x plus h and x plus h. I can now combine my numerators over one common denominator. So the common denominator is x plus h. To combine the numerators, it's going to be x minus, and this is why the parentheses is good. If I had lost the parentheses, I might miswrite this. If I'm going to actually combine my numerators now, what's going to happen is that negative sign, this negative must get distributed to both things. And a lot of times what I would see here is people would say, oh, do x minus x, and it leaves me with h. Well, that's not completely correct because the negative gets distributed to the h as well. So really what we have on top is negative h. And then what we've got on the bottom is x plus h. And nothing else can divide out there because the h in the denominator is grouped with the x, so it cannot divide with the h on the top. So that's it. We are simplified down to one fraction in this case. Okay, so let's go ahead and look at the second one. In the second one, what we have is we have the division of two rational functions. Okay, there are no additions or subtractions. Everything here is some kind of a multiplication or division, which means that everything is a factor of some kind. So when we have things like this, when we have just factors, when we divide fractions, the rule is that you take the denominator, you flip it or multiply it or make it a reciprocal, and then you multiply. So when you divide fractions, you take the top fraction or the first fraction and you multiply it by the reciprocal of the bottom fraction. So what we're going to do is we're going to rewrite this as 2 over x squared times the reciprocal, which is basically means flip over the fraction, x to the 5th over 10. Okay, when you multiply these things out, you get 2x to the 5th over 10x squared. But that can simplify because 2 goes into both the numerator and the denominator. So 2 goes into itself 1 time, 2 goes into 10 5 times. I've got x to the 5th over x squared. Well, basically, x to the 5th means I have 5 factors of x. If I was going to write them all out, I would write x times x times x times x times x 5 times. And in the denominator, I would write x times x. So what you would get is that 2 of the factors from the denominator will divide away with 2 of the factors from the numerator, which really just leaves us with an x cubed, because you'd still have 3 factors of the numerator. So ultimately, what we get here is x cubed over 5. Once again, that is simplified. It is down to one rational function. Okay, there are multiple ways to do number 3, and it's really going to depend on what's best for you as to how you do this one. I prefer to use the method of I'm going to find the common denominator of all of the individual fractions. So what I can see is a couple of different things. I can write the denominator, by the way, as x over 1, and it's still x. So that doesn't change anything. If I look at all of the denominators, what I have is I have 3 plus x, 3, and 1. I have to figure out what all of those things multiply into. Well, again, the easiest thing to do, first of all, treat this denominator right here as if it's in a parentheses. And we're just going to say, well, 3 times 3 plus x times 1 is the common denominator. I don't really have to worry about the 1 because you can multiply anything by 1 and it doesn't change. So my common denominator is really 3 times 3 plus x. Personally, what I prefer to do is I prefer to say, okay, I'm going to multiply this big fraction. Hopefully you can see that there is one big fraction here, which is separated by the littler fractions. I'm going to take this big fraction, treat that whole thing like it's a parentheses, treat that whole thing like it's a parentheses. And I'm going to multiply the numerator and the denominator times the common denominator. Okay, so what you should be able to see here is, if I were to multiply this whole thing times this first fraction, it gets multiplied only by the numerator of that, only by the 1, because if it's basically a whole number, 3 times 3 plus x is basically a whole number times a fraction, it only gets multiplied on the top. What's going to happen is this 3 plus x is going to divide out with that 3 plus x, which is going to leave us with just 3 times 1 on the top, which is 3, minus. We're going to do the exact same thing. Now we're going to take this whole thing right here, and we're going to multiply it by the second fraction. Okay, what you should see now is that the 3's are actually going to be the things which will divide away, which leaves you with the 3 plus x in this one. Again, remember, this should be in a parentheses. But what that does is it gets rid of that whole compound fraction thing on the top. And then in the denominator, I'm going to multiply the 3 the 3 times the 3 plus x times this x. We can put it over 1, but again, there's really no reason to. So we're going to get 3x times 3 plus x. And then we're going to simplify. Well, again, the numerator, remember, don't forget, the negative sign gets distributed to both pieces. So it's really 3 minus 3, which is 0, and then minus x on top. So what I'm going to get here is negative x over 3x, 3 plus x. But there's still one more thing that we can do, because what I do have on the top is a factor of x, and I have a factor of x in the denominator. So those two factors do divide away, and that doesn't leave you with nothing on the top. I still have that negative, so it really is a negative 1 on the top. So what I get is negative 1 over 3 times 3 plus x. And I kind of ran into my room, but that's okay. I'll make more room on the right-hand side here of this last problem. All right, the last one. We've got a bit of work to do here. This one's going to take the longest, but it won't be that bad. So in order to do this, what we need to do is we need to factor all those denominators to see what all the different factors are that we're going to need to get a common denominator. So let's just go ahead and start rewriting this. Oops. Should be a 2x on top. The first one is going to factor. As a matter of fact, that's actually a special one as well, but it factors the same way anything else would for a trinomial there. So that's got to be x and x. In order for me to get the positive 9, it's going to end up being minus 3 and minus 3. Because if I now do the FOIL process and check it, you would get the minus 6x in the middle and the plus 9 at the end. So that's the two factors there. Technically, you could write that as x minus 3 squared, but we're going to keep it as x minus 3 for now. Okay, nothing is going to change on the second one. There's no additional factors. I am going to put the x plus 1 in the parentheses. And then on my numerator here, it's just 8 on the last one. And we're going to factor that one to x minus 3 and x plus 1. So what you should see is I've got a bunch of x minus 3s, x plus 1s running around here. I also have a multiple of x minus 3 and one of them. So what you have to do is this. Here I've got 2x minus 3s. Here I've got 1x plus 1, and here I've got a combination of both of those things. Each one of these fractions is missing one piece that the other one has. And you might say, well, wait a minute, I've only got x minus 3, but I have two factors of x minus 3 in the first one. So that means I have to have two factors of x minus 3 in all of them. Okay, so let's go ahead and work this piece by piece. The first piece here has two factors of x minus 3. It's missing an x plus 1. Okay, because each one of the other two pieces has one factor of x plus 1, which means I'm going to have to multiply this by x plus 1 and x plus 1. Okay, that's going to be how we're going to get that to work. Now, in order for me to get the common denominator in the second one, which is x minus 3, x plus 1, it's missing both of the x minus 3s. So this one has to get multiplied by x minus 3 x minus 3 on the top and on the bottom. Probably should have left myself more room. And then on the last one, it's got one of the x minus 3's and an x plus 1, so the only thing it's missing is the extra x minus 3. So it must get multiplied by the x minus 3. Okay, so now we've got our common denominator, which is going to be x minus 3, x minus 3, x plus 1. So now what we're going to do is we're going to go ahead and multiply out all of the numerators, and then we're going to combine like terms and then see what we get. So on the top one here, we're going to get 2x. Don't forget to distribute to both pieces. So that's going to be 2, oops, didn't mean to hit my eraser, 2x squared plus 2x. That takes care of the first one. And the second one here, I'm going to put all this thing in a parentheses because it is minus, so it's subtracting all this. X minus 3 times x minus 3 is going to be, well, x minus 3 is exactly what we had there in the beginning. So I know that that's going to be x squared minus 6x plus 9. And then in the last one, once again, because I'm subtracting it, I'm going to put it in a big parentheses here. Don't forget to distribute the 8 to both pieces. So that's going to be an 8x minus 24. All right. Like I said, I did not leave myself with a lot of room, but let's see if we can get this to work out right here in this little space at the bottom here. So if I combine all of my x squared terms on the top, I've got 2x squared. Technically what I have here is I've got a minus x squared because of the minus sign out front. So 2x squared minus x squared is going to be x squared. Here I'm going to have 2x. See if I can do this in a different color here. We're going to have 2x. I'm going to have minus 6x, which is really plus 6x, so that's 8x. And then minus 8x, that's actually really nice. Minus that 8x, that's gone. I have no x terms left over. Wonderful. Last thing I have to do, and because glad it's the last thing because it's getting kind of messy, is I have to deal with the constants. So what I have here, and I have to be really careful about this one, is I have a minus 9, and I have a minus 24. Well, the minus is plus 24, but the minus 9, so it's 24 minus 9, which is going to be 15. So what I've got here is x squared plus 15, and then over my common denominator, which is x minus 3, x minus 3, x plus 1. And that is simplified. All right, so there you have it, your 2 lessons. Again, I spent more time probably on these things than I would like to have, but I wanted to make sure I went into enough detail with the terminology to make sure you guys are really understanding what's going on. Any questions, feel free to ask. We are here for you. Again, this is just good preparation, and that's the end of week 1.